So I've got a new helmet, which is great. The old one was getting a bit tatty and tired. The trouble is, of course, that gives me the problem of fitting the Bluetooth headset, but also the camera. I have a camera on mine most of the time as a kind of dash cam. So I need to fit it onto this curved surface. As usual, I have a Garmin camera, this one in fact, which is great, but it comes with mounts, which actually are detachable, which is quite handy. But one is a flat mount and the other has a curve, which sounds great. The trouble is that the curve isn't right for my helmet. So if this is on here, the curve is too tight. There's a distinct gap. I don't know if you can see that on the camera, but there's quite a big gap here. So the curve is too tight, and it would probably press on with the foam, double-sided sticky foam, but it's going to be under stress, so it's going to drop off, as I've had happen before. So the answer is to make a 3D printed shim, as it were, or a pad. So this has got a curve on it on one side and flat the other. So I've 3D printed this, and with this pad, this pencil line is where I'm going to mount the camera. This pad is pretty much a perfect fit for the curvature of this helmet. So with that on, with some sticky pads on this side, the flat-sided mount will fit perfectly on the other side. So that works really well. I've done it on other helmets, and it works a treat. The curvature of this is actually it's curved to radius in this direction, and another radius in this direction. So it's got a double curvature. So to work out what those two radii are, the radius in this direction and the radius in this direction, what I do is put a straight edge against one end and get it by eye at a tangent to the surface here, and then measure the gap at this end, which I can do with a caliper depth gauge. So I can measure that, get the two lined up, which is about there, and that comes out at 4.5, no, doesn't it? 6.6 millimeters. In other words, the gap here is 6.6 millimeters. If I do the same this way, again, touching at this end and measuring the gap at this end across that distance, then that works out to be, yeah, that is about, if I can get this thing right. Yeah, and this for this particular helmet, it's 4.5. So with those dimensions, together with the overall size of this patch, which is 55 near enough by 36, so I've already measured this. That's all I need. I've got a program in OpenSCAD that will take those dimensions, the length and the width, together with the fall over the curvature of this helmet, and work out what these two radii are, and therefore sort of carve out this shim, which you can then 3D print. So I've got those measurements in this fairly short OpenSCAD file. I've got here the thickness of the overall thickness of the pad, the minimum thickness, then the width and the height, and the gaps that we've measured on the helmet itself. So this is 55 wide, 36 is the other dimension, and the gap is 6.6 on the long side and 4.5 on the short side. And if you put that into the program and run it, then it generates the pad, which is there. So that's got the curve in this direction, which is worked out from that gap measurement, and the curve in the other direction. So printing that will give us the correct pad, hopefully. So, having printed the shim using the CAD software and 3D printer, I've got some of this VHB very high bond strength 3M tape, which I would thoroughly recommend. It's good stuff, especially in the slightly thicker type if you can. I think it comes in 2 thicknesses, but I'd definitely go for the thicker version. Gives you slightly more compliance. Anyway, I will stick that onto the curved side. There's the 2 strips of tape on. Just trim this outside edge. And this one. Okay, so I now peel off the backing on this side. Okay, so there's the double-sided tape on the pad. Stick the pad in the right place on the pencil marks. There we go. So you've got a nice full contact bond with no stress other than the stress that you put onto the plate, and the flat surface that the camera pad, wherever it's gone, here, this one, so that can just stick on there. And between those 2 pads, the foam pads, should have a nice unstressed bond to hold the camera. So there we go, full mount on. So this camera will then mount onto there, clips on, just that position, and I'm good to go. I'll leave that for 24 hours. Then they recommend leaving the VHB 3M foam for 24 hours before you actually put any weight onto it. So I'll do that, put it in a warm place and just keep it squished together, and that should be fine. Okay, I hope that's helpful. The software, the CAD program is on Thingiverse. I'll put a link to it in the description if anyone wants to use it. So it's pretty straightforward to use, and maybe it'll be useful. Okay, thanks for watching.